Hello everyone, welcome to the Learn TSL channel. Today, we're going to use Three.js TSL to recreate the flowing color effect you just saw. If you've always been curious about shaders but felt they were too complex, trust me, TSL will open your eyes. We'll start from a completely blank file and go step by step until you fully understand the principles behind it. Ready? Let's go! Right now, our color plane tsl.jsx file is empty. The first step is to set up the basic environment with Three.js and React 3 Fiber. We import Canvas, which is the surface for all our 3D content. Then here's the key part. We bring in WebGPU renderer. TSL, short for Three.js shader language, is built on top of WebGPU. So inside the Canvas component, we need to explicitly enable WebGPU. It's simple. Instead of using the default WebGL renderer, we tell Canvas to use our WebGPU renderer. Done. This is the most important setup step. Great, we now see a visible plane. That confirms our scene, camera, and renderer are all working. Now the magic begins. To turn static white into flowing color, we replace Mesh Basic Material with its TSL version. The core idea of TSL is node-based design. Think of nodes like Lego bricks. By combining them, we can create any effect we want. All these nodes come from Three.js TSL. Before writing code, it's crucial to understand a few of them. First, let's talk about positionLocal. What does this mean? You can think of it as the model's own local coordinate system. For our plane, the center is at 0, 0. The left side is the negative x direction, the right side is positive x, the top is positive y, and the bottom is negative y. The positionLocal node gives us access to each pixel's local coordinates inside the shader. This is the foundation for creating gradient effects. Time is simple. It's just a continuously increasing value, and it's the key to making animations move. Next, sin is the familiar trigonometric sine function. It generates smooth values that oscillate between -1 and 1, making it the perfect choice for creating flowing color transitions. Finally is color. This one is very straightforward. It acts like a color assembler. In shaders, colors are usually expressed with 3 or 4 numbers, R, G, B, and sometimes A. The color node's job is to take the separate red, green, and blue values we've calculated and pack them into a final color vector that the GPU can understand. Alright, that's enough theory. Let's put it into practice. We switch to Mesh Basic Node material and register it with Extend. Unlike the standard material, it takes a color node instead of color. This is where we plug in our node logic. Let's construct it. For the R channel, we take positionLocal.x plus time, feed it into sin, and map the output from -1 to 1 into 0 to 1. That gives us a red wave moving horizontally. Here, I just copied it directly. For the G channel, we link it to positionLocal.y, adding vertical variation. For the B channel, we reuse the red channel, creating a nice purple-pink tone. Finally, we combine them with the color node. And look, it's moving! We've brought this plain white surface to life using just a few simple nodes. But why does sin x plus time create this animation? Take the function f of x equals sine of x plus 1 divided by 2. Its values always stay between 0 and 1. Imagine the x-axis as our plane's horizontal direction. Each point's x-coordinate maps to the sine curve and its height determines brightness. When we add time, sine of x plus time, the entire wave shifts smoothly as time increases. On the plane, that looks like a flowing horizontal wave. The green channel adds a vertical wave, and together they blend into the dynamic color effect you're seeing. Now let's review what we just built step by step. We set up React 3 Fiber with a WebGPU renderer. We learned the meaning of key TSL nodes like positionLocal, color, time, and sin. We combined them Lego style to create a dynamic flowing color effect from scratch. I hope this video helps you take your first step into TSL. If you found it useful, please like and subscribe. It makes a big difference. In the next video, we'll explore more fun TSL nodes, including noise-based effects. Thanks for watching, and see you next time.